Hello everybody, this is Unit 4 still, Day 2 completing the square. Some of you would have completed this process in grade 10, some of you who have not. We'll go through a number of examples and list the steps out so that you understand this process fully. First, let's start with a little bit of a warm-up, going back to what we did a couple units ago in terms of factoring quadratics. And we have two quadratics here in standard form. I'm actually going to start with problem B. Just because I believe it's a little easier to start with. So start with problem B, which is this one here. Okay, so if we factor quadratic in standard form, remember we're looking at two factors or two values that multiply to C and add to B. Remember, our quadratic in standard form follows this general form, ax squared plus bx plus c. So we're looking at two values that multiply to C and add to B. In this, our C value is positive 16, and our B value is 8. Okay, as we've done before, we're going to set up our little t-chart off to the side. Okay, we're looking at values that multiply to 16 but add to 8. So just start going through your factors of 16 in order to do this. Easiest way to do that is start at 1. So you have 1 times 16. You can't add those two numbers together to get 8, so you keep going. 2 times 8. Again, you can't add to 8. And then 4 times 4 would be the last set of factors. And if you notice, 4 plus 4 also equals 8. So those are the two factors you're going to look for. Okay, I'm going to go through the whole process of what we call factoring by decomposition here, just so everybody can understand kind of and recall factoring. So first thing you want to do, and why we call this factoring by decomposition, is you want to split this middle term into the two factors that we identified in the table. So I'm going to put plus 4x plus 16. So the C value stays the same, but that middle B term has now been split into these two factors that we identified. So if those factors were 2 and 6, then I would write plus 2x plus 6x in the middle. The next process you want to go here is you're going to look and you're going to group these two things. You're going to group your first two terms and your second two terms. And when we continue here, we're going to essentially common factor each of those pairs of terms. So what is common between x squared and 4x? Well, x is common here. That leaves us, if you factor it out, x plus 4. Okay, and next we look at 4x and we look at 16. Well, what's common amongst those two terms is 4. So if you factor out 4, what is that left with? X plus 4. And your last step, you write out, well, what do you see that is the same? You see x plus 4, which is the same, so you're going to write that out. And what do you have left over? You have x and you have x plus 4, so you're going to write out x plus 4. And reminder, anytime you see something that is similar like this at this step, you're going to rewrite this with proper math notation as x plus 4 squared. Now pay attention to that, because we're going to run into something very similar in our other problem. Okay, so we're going to jump over to problem A. And again, we're going to set up our t-chart, except for it's a little bit different. In this problem, we have an A value of 4 and not 1. So we're not looking simply at values that multiply to our C value of 25. We're looking at whatever A times C is, which is 4 times 25. In other words, we're looking at values that multiply to 100 that add to negative 20. If you go through those factors again, you can start with 1. For sake of time, I'm going to identify those factors to you. It would be negative 10 times negative 10 equals positive 100, and negative 10 plus negative 10 is equal to negative 20. So you're going to go through the same steps here, and you're going to split that middle term of negative 20x into negative 10x negative 10x, and your c value remains the same. Same process here, you're going to want to group those first two terms and those second two terms. Okay, and you are going to factor out what's common. Well, in this problem here, you look at what's common between 4x squared and negative 10x. Well, they both have an x in common. Well, what is the greatest constant or factor that you could factor out of 4 and 10? It would be 2. So if you factor that out, 2 and x, you're left with 2x minus 5. Okay, you look at negative 10x and you look at 25. What's the greatest common factor you can pull out of them? Well, they don't have a variable in common, so you're only going to be able to factor out a constant, which would be negative 5. And again, if you leave what's left, it's 2x minus 5. So again, what is common? You see 2x minus 5 is common in the brackets. You rewrite that. And what is left over? 2x and negative 5. And again, we get something similar to the last problem, where we're going to have to rewrite 2x minus 5 squared. Now, both of these problems would be what we call a perfect square. Okay, what is a perfect square? Well, it's a value in which you take another factor and you multiply it by itself. For example, 9 is a perfect square because it's 3 times 3. 16 is a perfect square because it's 4 times 4. 25 would be a perfect square because it's 5 times 5. These actual quadratics, 4x squared minus 20x plus 25 and x squared plus 8x plus 16, that we see here are both examples of perfect squares, where if you were to factor them at the end of the problem, you're going to get a binomial, for example, 2x minus 5, that if you multiply it by itself would result in that original quadratic equation. Now, it's important to understand what a perfect square is because we're going into the process of what we call completing the square. And completing the square is essentially the process we use to convert a quadratic from standard form to vertex form. Okay, this chart right here, you can keep it handy with you whenever you're working through your problems, and it goes through those steps. And we'll make a couple extra notes right now to help you out. But it really breaks everything down here, and we're going to take a couple of days to go over this concept, so don't worry if you don't get it just at first. So here's our equation, 4x squared plus 24x minus 7. The first step you see here is factor the a value from the x squared and the x term, and that's what's happened here. So that we have factored out 4, which is our a value, from both our x squared and our x term. Well, if you divide 4 out from x squared, you're left with x squared. If you divide 4 out from 24x, you're left with 6x. Okay, that's step 1. And then you leave those two values inside of the brackets. The next one, and this is where it gets a little bit tricky, you find a constant that must be added to create a perfect square. In order to do that, and that's kind of what's explained here, you're going to take this little formula, b divided by 2 squared. Well, in this problem, the b value I had is 6x. So I'm going to take that 6, that constant in front of it, and I'm going to plug it in for b. 6 divided by 2 squared, well, 6 divided by 2, what is that? That would be 3 squared equals 9. And that's where you're going to see this plus 9, negative 9. So once you've plugged in that b value, you've solved that small little formula and you get a value. You're going to keep the expression equal by adding and subtracting the number inside of the brackets. And that's what you see there in blue as plus 9 minus 9. Okay, the next one, you're going to remove the negative value, so that negative 9, by using the distributive property. So you would do 4 times negative 9. So distributive property meaning that 4 in front right here, you're going to multiply it by negative 9, and that's how you kind of end up with this negative 36. Okay? So every time you take that subtracted value, whatever your a value is in front, you're going to multiply that, and that's how you get negative 36. And the last step, you're going to do two things in one. you're going to factor the perfect square and simplify the constants outside of the brackets. So the constants outside of the brackets, well, -7 minus 36, that gives you -43. You've essentially just collected like terms. Now it also says factor the perfect square. It's referring to what you have here in brackets, x squared plus 6x plus 9. Now if you went back to the process that we started with today and you actually factored that problem, you would be left with x plus 3, x plus 3 squared. And that's how you kind of get to this point. And that essentially would be completing the square. Another way you can look at this, and you can almost take away that process of factoring and just look back at a previous step, is if you look up here in this formula that you did, okay, you notice the value you got inside of the brackets at the end of this was 3. Okay, and you notice you also see 3 right here. Every time, whichever value you get inside of that bracket is going to be what you have at the end of your problem. So if that value was 4, your end answer would say x plus 4 squared. Okay, so just pay attention to that when you're going through these things. There's little tricks in some of the problems. Okay. The easiest way to do this is to go through some examples. So we have 3 examples. They all have different types of equations. You notice this one here has an a value greater than 1. This one has an a value of 1. And this one here is essentially missing a c value. So we're going to go through these examples. If you understand this process after example 1, you can stop the video there. If you still need a few more explanations, continue through this video and listen to the differences amongst these problems. So I'm just going to draw a line here to kind of separate this information. Okay, remembering the steps that we need to go through. So if you need to go back to the first page and have that beside you while you do this, please do. So the first step we want to do is factor out that a value from our x squared and our b, or our x term. Our a value is 6. I'm going to factor that out. Okay, that leaves me with x squared. Well, 48 divided by 6, that leaves me with 8x. And essentially, that's what I've done, is factor out a. The next part is you're going to take that little formula and you're going to essentially decipher what that value is that you're going to add and subtract inside of the brackets. So our b value now is -8. So take that -8 and plug it into your equation. That little b plus 2, sorry, I'll start this again, which is -8 divided by 2 squared, well, that equals -4 squared, which is 16. So I'm going to plug that in as adding it and subtracting it inside of the brackets. The next part of this is we want to use distributive property to multiply that initial a value by the subtracted value in our bracket. So 6 times -16. And then it will be removed from our bracket. So 6 x squared minus 8x plus 16, close bracket. Well, 6 times -16 is -96. And you still have that plus 3 there. Okay. The last 2 things we need to do is we need to collect our like terms outside of the brackets. Okay, which would be -96 plus 3, which I hope we can do that without a calculator. -93. And what we also need to do here is make sure that we factor the perfect square that we have left in our brackets. Now you can do this on the side if you want to actually factor that whole thing using a t-chart. So you'd be looking at 2 values that multiply to 16 and add to -8, which would be -4 times -4 and -4 plus -4. Or you can go back up and again look at what you had left inside of the brackets right here, which was -4. Okay, if you do so, your resulting answer should be 6x minus 4 squared minus 93. Okay. Okay, as you can see, you factored it, you have completed the square, you have now gone from standard to vertex form. Let's do another one here. This one might be even a little bit easier with an a value of 1. Okay, first thing is we're going to factor out that a value of 1, and all that means in these situations is you're going to rewrite these first two terms inside of the brackets. Okay, you're going to plug that b value of 10 into our little formula here and see what you get. Well, 10 divided by 2, that's 5, squared, that's 25, and you're going to now add and subtract that value inside of your brackets, plus 25, minus 25, and you still have that plus 30 at the end. Here, because our a value is 1, and we want to use, just like our first example, here we wanted to use distributive property. Well, 1 times negative 25 is still just going to be negative 25. So essentially you can just remove that negative 25 outside your brackets. Here you would like to collect those terms, which would be negative 25 plus 30 is positive 5. And then we're left to factor that perfect square inside of the brackets. Well, if you factor it in the t-chart, two values that multiply to 25 and add to 10 would be 5 times 5 and 5 plus 5. Or again, if you go right up to that problem when you typed in that little formula, you notice that 5 is right there. Okay, so your final resulting equation is x plus 5 squared plus 5. And you've completed the square again for about a value of 1. The last one we have here is a little bit different in the sense that there's no c value. It doesn't change the process. Every step is the exact same. You're actually just going to have to do a little bit less. So here, you're going to want to essentially factor out that a value, which is negative 3. That leaves you with x squared minus 4x. Okay. Here you're still going to go through the process. Well, our b value right now is negative 4 that we're working with. So b divided by 2 squared. Plug in that negative 4. What are you left with? Negative 4 divided by 2. That's negative 2 squared, which is equal to positive 4. So you're going to add that value and subtract that value inside of your brackets. Okay, you're going to use distributive property now again. So 3 times negative 4 to bring that negative value outside of the brackets. And sorry, that initial term is negative 3. So this actually 3 times negative 3 times negative 4 is positive 12. Okay, and the only thing we have to do now is factor our perfect square that remains in the brackets. Well, what multiplies to 4 and adds to 4? 2 times 2 and 2 plus 2. And again, if you look up to that process, what do you see here? You see the fact that it is negative 2. And sorry, this down here in their chart would be adding to positive 4 and multiplying, or adding to negative 4 and multiplying to positive 4. So you're left with 3x minus 4 squared, or x minus 2 squared plus 12. Okay, and that is the overall process of completing the square. If you have any questions, reach out. If you just need to go over that a few more times, please do. Complete the assigned questions, and our next day we'll be looking at completing the square with fractions involved. All right, thank you very much.